Hi everyone, today we have a normal distribution paper 1 style question. So the mass W of Manx cats is normally distributed with a mean of 4.5 kilos and a standard deviation of 0.4 kilos. A Manx cat is selected at random. Calculate the probability this cat's mass is more than 3.5 kilos. So first thing, we need to write it using the correct notation. So what we want is, for part A, we want the probability that W, because back to my question, we're using W as the variable. We want the probability that W is greater than 3.5. Equals, and that's where I'm going to write my answer in a moment. Now we need to go to my calculator. So I'm going to go stat mode. I'm going to go distribution, F5 at the top. I want a normal distribution, and I want NCD because we don't want a specific value. We want a range of values here. So NCD, make sure it's set to variable. We're going to change this lower one. So it says more than 3.5. So that means from 3.5 up. So 3.5 is going to be the lower. The upper, I just want to change the upper so it is significantly higher than anything that we would expect. So we've got weights of cats. So if I do 100, that is a really large number in this context. And it doesn't ultimately matter, but I just want a really large number so that I'm getting all of the detail, really, essentially. Standard deviation is 0.4. The mean is this value is 4.5. And execute. So we've got the probability is 0.994. That is to 3 significant figures. Next, B. I'll go down a little bit. We want to find, so it says the following curve represents this distribution. It is known that the probability that W is less than A is 0.1. That means that area in gray is 0.1. And the probability that W is greater than B is 0.1. So essentially, A represents the bottom 10%, B represents the top 10%. We want to find the value of A. So for B, for the question B, A equals, we need to go back to my stat mode, exit, distribution, normal, inverse normal this time. We want a left tail. If we're looking at A first, we want the area from the left to be 0.1. The standard deviation is the same. The mean is the same. Press execute, and we get 3.99. So 3.99, that is the value of A. The value of B, B equals essentially the same thing, but now we just need to go back to the tail and we need to change it to a right tail. Press equals, and we get 5.01 is B, 5.01. And on the mark scheme, we need to use our GDC, so calculator, to find either A or B. So you could say on your calculator steps, GDC, inverse, normal, and then you could state what the mean is, state what the standard deviation is, and then say left tail 0.1 or right tail 0.1. So that is for B. For C, it says 2 Manx cats are selected at random from a large population. find the probability that they both have a mass of less than 3.5 kilos. So if I'm working out the probability that two things happen, I need to multiply those two probabilities together. So before we even do anything with this question, I'm going to say the probability that W is, this time we want less than 3.5. So we want less than 3.5, and then we're going to multiply that by the probability that W is less than 3.5. That satisfies the question. Two Manx cats are selected at random from a large population. Find the probability that they both have a mass of less than 3.5 kilos. So we've set up the question. Now let's go back to my stat mode. Let's go distribution, normal, NCD. This time we want the lower to be 0 and we want the upper to be 3.5 because 3.5 is the top of this situation. We want W to be less than 3.5. Standard deviation is the same, the average is the same, and execute. So we get that as a number. That's the probability of only one of those things happening. So this says 6.2097 times 10 to the negative 3. So that's scientific notation. So we can move the decimal place over. So we're going to get 0.006297 multiplied by that same number because it's going to be, the probabilities are the same. So multiplied by 0.006297. Now let's get an answer for that. So 0.62097. We can just do it squared because that's the same thing. And we get that as a number. So this is going to equal 3.8. Let's do 3.86 times 10 to the negative 5. Or we could also, if we wanted to, we could also write that in decimal form. So that's going to have 4 zeros. So 0.1234386. That is the probability. So you can see that is a very small number. That last one is worth 2 marks. So you needed to multiply two identical probabilities, and then you would get a final answer of 0.0000386, and you would get another mark for that being the correct answer.